Okay, let's work out the question number 9. And this is also to be solved by using properties. Here it is mentioned, in the previous case it was not mentioned. Anyway, you can solve that one because there was not mentioned any kind of methods. So we will not mention that how to solve that problem. That's why we have used properties, right? Now here it is mentioned, so clearly you have to follow the properties, to use properties to solve this, right? First one, let us take left hand side. Using distributive law, A union A union A, then intersection, then A union B, using distributive law. Now A union A union B will remain same. You know which one is larger part. A is this one. Suppose B is this one. This is A union B, the whole part, right? Now A union B is representing this whole part, right? And then with this we have to find intersection of F. So what is the common part here? This part only, isn't it? So this is equal to A, which is our right hand side. Okay, let us work on the question number 2. From left hand side, A intersection A union B, and again applying distributive law, A intersection A union A intersection B. A intersection A is A union A intersection B. Now you see which part is larger. This is intersection part or the set itself. Intersection part or the set itself. Which part is larger? Intersection part means common parts. Common part will be the either equal or less than this one. Always union of two sets produces the larger one, isn't it? So this is A. Right hand side proved. So this is question number 9. Okay, let's move to the next question, question number 10. So what is here? So that A intersection B is equal to A intersection C need not imply B equal to C. Through example we will show this. So for that, let us consider, let A is equal to suppose 1, 2, 3. Then B is equal to 3, 4, 5 suppose. Okay. Then C 2, 3, 6. Got it? Now let's find out A intersection B and A intersection C. Are they same? So because this is the precondition, after being satisfied this condition, we have to show that B is equal to, we have to show that B is not equal to C. Fine? So A intersection B will produce, A intersection B will produce only 3, isn't it? So therefore A intersection B is equal to 3. This is the common part. Okay. Then you find A intersection C. Here we will get 2, 3, isn't it? But they are not equal. So we have to write C in such a way that their intersection and their intersection must be equal. So we have to change this C. How will you change? This 2, let us remove and then put another element 7 this way. So now what is the intersection of A and C? You will get, again this is 3 only. Okay. In that case, A intersection B will be equal to A intersection C. Okay. We have made these two sets equal. But what are you getting about A and C or B and C? Are they same, B and C? B contains 3, 4, 5 and C contains 3, 6, 7. Are they two sets equal? No, isn't it? So you can write B is equal to C is not a necessary conclusion. So let us take another question, and the question is, let A and B be sets if A intersection X is equal to B intersection X is equal to phi. That means X is disjoint to both A and B. Okay, that means X has no common elements with A and B. Then A union X is equal to B union X. This is the second condition for some set X axis and E set that is assumed, so that A is equal to B. So how do you prove that two sets are equal? For that we have to show that one of them is subset of the other and the other is also subset of the first one. So this is the main condition to prove that two sets are equal. Okay. So we will first prove A is subset of B, then we will show B is subset of A, and that is how we will reach our destination target. Okay. So here given A intersection X is equal to B intersection S is equal to phi, and A union X is equal to B union X. These conditions are to be used in our solutions. Okay. So since we know A is equal to A intersection A union X. So have you understood this expression? Actually A and this the same set A union X. So if you compare these two set, this one and this one, compare these two, which one is greater and which one is smaller? If you compare these two, then surely this will be greater than this one, because with A there is something added, X is added, or even if X is phi, then also A union X will be equal to A. In that case also A intersection A equal to A, isn't it? So anyhow, whatever be X, no problem, your this expression will give A. Okay. So from here A intersection A union X is equal to B union X. Let us substitute that. Then using distributive law, A will go with this, A will go with this. What is that distributive law? 2 into A plus B. How do you expand it? 2 into A plus 2 into B. This is how you expand, isn't it? 2 into A, then in the mid plus sign is to be substituted, then 2 into B, isn't it? So here what is intersection is there, and then this is union. Now intersection, and then union is to be put, isn't it? A, so intersection B union A intersection X. Okay, have you understood this expansion? Then we have A intersection B union. What is this? A intersection X is phi, that is given, and their union, we know A union phi is equal to A. This much we already discussed. So some set union with null set, so again produces the same set, because null set is the identity element for union. So nothing will happen here, only A intersection B is our outcome. Okay, now you see what happened. A is equal to A intersection B. Section of two sets are taken and then result is A. What does this mean? This means that B A and their intersection is only A. This figure shows that A is subset of B. From this concept, we can say that A is subset of B. This is number 1. Right? Again, B is equal to B intersection B union X. The same idea is being applied here. Okay, B is equal to B intersection B union X. This is to be replaced by A union X. Okay, then B is equal to B intersection distributive law. The same way we are applying union, then B intersection X. So to understand this, you please take the help of this multiplication. 2 into A plus 2 into B. This is the distributive law. So this is how we have distributed this. B equal to B intersection A union. This is given as phi. B intersection this. So phi, and this equal to B intersection. So which gives B subset of A. This is number 2. So combining 1 and 2. In the first case we got this. In the second case this. So this equal to this one. Is that it? What is to be written now? Combining 1 and 2. We get A subset of B and the B subset of A, which implies A is equal to B. That's our result proved. Okay. Thank you.